Hi, all. Marty Porter here, Executive Director of Silicon Valley Video. You also may know me from SVG. Quick plug, SVG has been working with a lot of the big tech companies over the last few years to build a new community in big tech and enterprise video, and we're excited to be back and virtually. As always, we thank our sponsors, Advanced Systems Group, big supporters, Dave Van Hoy and his crowd of folks from Emeryville, and we got Tom Baldessari from the studio B&H on. You all know Tom, the godfather of Silicon Valley, as he's well known, right, Tom? So we're here to share the love, to share some experience, get some real mind-blowing knowledge, and I'm real excited to hear what's the new stuff coming from NVIDIA when it comes to AI and video. But before we get into the program, I just wanted one quick additional plug, and just so you know what's going on with us. We've planned our big summit, guys, and it's still 6 months out, but I just wanted to make a big announcement here for the first time that the Silicon Valley Video Summit is coming to the Computer History Museum in Mountain View, California on January 26th. Our slogan is where video and broadcast meet big tech. Those of you who've been attending these meetings, and even before we went virtual pre-pandemic, you'll know that this is our mission. It's what we want to accomplish, and this will be our big kickoff. So if you have any ideas, you want to speak, know some blow-away speakers, please, you know where to find me, and we'll be in touch. But please keep this on your calendar, and you'll be hearing more about this in the weeks and months ahead. Also, we're on Zoom, so let's just use some basic etiquette. Here's how it rolls here. Mute your microphones. Nobody to say or do anything embarrassing, please. You know we've all been on Zoom calls. So select speaker view, not gallery, just so you can have the right experience in here. And we're using the chat window for our questions. So write it in the window. I'm not so sure all our guests will be able to stay through the Q&A, but we'll have Jeff Lowe, who I'll be introducing in a moment, who'll be here to ask some questions. And even if we don't get to your questions, I'll be jotting them down and I'll be sharing them with our guests, and they'll be following up. So with that said, I just wanted to do a quick introduction for Jeff Lowe. Jeff's been a friend of ours at SVG for many, many years. I don't know if we don't go as far back as your Apple days, Jeff, but we certainly go back to when you were building out the Hall of Fame in NASCAR. So we know each other from those days. Jeff landed at NVIDIA maybe about 18 months ago, I think, or maybe a little longer than that. And we were excited to see him going there. We know that NVIDIA is in the middle of all interesting things these days. And with a friend like Jeff there, we figured he'd give us some inside skinny on what's happening. So with that, Jeff, this is your show. We expect to hang on for a real mind-blowing presentation for about an hour, everyone. Jeff, you want to tee it up and take it away?
You bet. Marty, thank you very much. And yes, a huge fan of SVG for actually back to your second year in existence. I was at Apple. I am the global lead for professional broadcast business development at NVIDIA. I cultivate the broadcast partner ecosystem and portions of the media and entertainment market for the worldwide sales team. I'd like to introduce you to our two presenters this evening. The first one is Rick Champagne, who is our global head of media and entertainment industry strategy and marketing for NVIDIA. In this role, Rick works closely with our internal teams, customers, and partners in film, television, and broadcast industries to promote the advancement and adoption of pioneering technologies. Rick has a very long history of managing products such as Autodesk's 3ds Max and Maya, entertainment creation suites, as well as Softimage, Mudbox, and HPZ workstations. Rick will be joined by Sepi Motamedi, who leads global industry marketing and strategy for professional broadcast at NVIDIA, my partner. She manages the promotion and adoption of advanced technologies in the broadcast industry, including AI, real-time graphics, networking, and virtualized production. I'm going to take literally a minute to do a quick overview. Most of you probably think that NVIDIA means graphics, which is understandable since we invented the programmable shading GPUs more than 20 years ago, defining modern real-time computer graphics. Today, however, NVIDIA is powering the next era of computing. In 2006, the creation of our CUDA programming model and data center GPU platform brought parallel processing built originally for graphics to general purpose computing. The universe of supercomputing has expanded rapidly to incorporate AI, advanced data analytics, and cloud computing. The era of the CPU-centered monolithic supercomputer is coming to an end. The next era has begun, and this session is going to show you some of the ways AI is changing the way you will produce and distribute media better and faster than ever. So thank you all for being here. Rick Champagne, you ready to go?
I'm ready to go. If I can get the controls to share my screen here, we'll rock and roll. All right. Well, hello and thanks everyone for joining us today. Really excited to be here. As you all likely know, AI has emerged as the single greatest technological advancement of our time. It's no longer just a science project, from the way that we create content, the way we consume it. AI really is a technology that's enabling humans to explore untapped potential, basically. And so there are creative solutions that are now using these techniques with mind-bending results. And we're going to show you some of how it's come to life in commercial applications, but also some of the research that's going on. So let me start with a video being at SVV.
I am AI. Accelerating your discoveries to solve the great challenges of our time. I am a visionary, bringing characters to life with more natural movement, generating brilliant new worlds for them to explore, and inventing new ways to bring out the creative genius in us all. I am a protector, leading the way into the most dangerous environments and searching for signs of life. I am a navigator, finding safer paths for cross-country deliveries and taking personal travel to new heights. I am a healer, giving hope to those who suffer from the most challenging diseases. And tapping into the brain to rejuvenate paralyzed limbs. I am even the composer of the music you're hearing. I am AI, brought to life by NVIDIA, deep learning, and brilliant minds everywhere.
All right, well, many of you know NVIDIA because of our leadership role that we played in gaming for decades, really. And but as Jeff mentioned, that's only a small part of it. The GPU, the chip that powers those gaming experiences, turns out it's also really good for powering these transformational technologies. So like autonomous vehicles, robotics, and of course AI. And so the chip can't do it on its own. So NVIDIA has created a full stack cloud native platform for computing and for AI. Which is really grounded on partnerships and development. So we work closely with people like you to bring these solutions to life. And so we're roughly 24,000 people now, if you haven't heard the latest. And we have more software developers than hardware engineers at this point. So from early stage research to powerful GPU accelerated SDKs, software platforms, and entire systems for really solving data center scale problems. And we partner with our OEMs and developers and software providers really to create those solutions that end up on, and we're focused on media and entertainment here, so really that end up on virtual production stages, in edit bays, and in control rooms and that sort of thing. We also acquired Mellanox a few years ago, you probably heard, and really what we've been working on there is delivering the future of compute. And so we're workstations and fleets of workstations can basically operate as a single computer operated by one pane of glass. And again, that's just that whole mentality of thinking about data center scale for solving the world's biggest challenges. And so IP transport's also being accelerated by our GPUs, but also our DPUs, our SmartNICs, our switches, and of course our software stacks. So it's really the marriage of software and hardware that's allowed us to really go well beyond Moore's law and accelerate computing. And so I'm just going to keep hopping through here. And so from a media and entertainment point of view, we're really looking at a number of different forces shaping the industry, from ultra high resolution video, high frame rates, HDR, all of that good stuff, but also, you know, looking across the spectrum of challenges that the industry is faced with. And so we're in the middle of major shifts of how content's created, distributed, and consumed. And then, of course, we're starting to see new types of content tailored for mobile viewing environments and different platforms like XR. And so these are just a few of the areas we're tackling in media and entertainment, and how AI is playing a heavy role in each of them. And so, for example, each of the trends we just looked at, NVIDIA has a full stack of hardware and software that accelerates them. And there's AI in every single category. And so I'm going to be focusing largely on content creation today, and then I'll hand over to Sepi. She'll talk about content management, content distribution, and content consumption. And we'll be talking about AI throughout the whole thing. And so really the question that we want to answer today is, can AI enhance human creativity? And the answer to that, of course, is yes. And it's a well-known quote out there in the industry. And I apologize for the noise in the background. It seems there's somebody out there doing some work. So AI is opening up creativity for everyone. This is an amazing time, really. We're seeing lots of different solutions and research coming to life. The first example you're seeing is StyleGAN, to generate new humans and also stylize them. And you'll see more on that later.
It's dangerous to go
and
alone.
This is an example of audio-driven facial animation.
You require more Vespine gas.
So again, you'll see more on that after too. The next example is character locomotion. And so with this one, basically AI is able to do character locomotion for like an infinite number of different positions, and it can also negotiate arbitrary paths and obstacles. If it was to walk up a hill, it would lean forward like you would in real life.
Take this.
He wants to keep going there.
You require more Vespine gas.
So the next one is video to 3D, and so this is reconstructing 3D from video, which is showing a lot of promise today. I'll show you some more examples with Ganverse 3D. This is physics simulation, and this is just using AI to do a cloth sim here. And then, of course, our optics renderer for denoising, so ray tracing, of course, in early stages. As it's delivering a ray to the screen, it is, you're just seeing partial view of what has resolved. And so denoising helps get you a cleaner image faster. So really, what's happened here is that there's a limitless possibilities, honestly, with AI. And over the past several years, there's been this explosion of AI development from researchers and engineers all over the world, and models for everything from speech recognition, translation, to generating synthetic people and pets. We'll talk about pets. Not knowing the full list of who's here and the varying levels of understanding of AI, I'm sure some of you are very advanced, so I'm going to apologize in advance for really simplifying this down. But we've got a lot of content to show, and I won't go too deep, but I'll go just enough to whet some people's appetites. And so let's dive in here. So. First of all, it's all about the data. You need data, and a model gets trained by making associations with data. And so you typically need more than just an image by itself, although there are cases where you can do some cool things with a single image. But you can, for example, if you've trained a network on how to identify cats and dogs, you need to tell the network, hey, these are cat images and these are dog images in the form of tags or metadata. And so the association is key, and knowing what you have and what you need is the starting point for creating a solution. And so it can be helpful to think about it as learning a way to map samples from your inputs to your outputs to create a solution. And so really it's determined on the questions that you want to ask about of the input data, and then the question itself indicates the type of deep learning task you need to perform to get to map the input domain to the output domain. And so you're seeing some examples here, basically. So these are just different questions you might ask. There are inputs, of course, text, images, video, audio, and then you may ask yourself, well, does this require a yes or no answer? So, for example, do you see a face in this video? And that's in the first example there. If it's a question that requires an answer describing the types of things that are inside each input, the task is called classification, and that's whose face is it? And then if there's a question that requires a shape or volume as an answer, the task is segmentation, and so where in the image is the face? And in fact, there may be multiple. So if it's a car and you're trying to determine who's in the car, you can there may be multiple people in that. So those are just some examples of the how to solve these problems. You really need to have that. And so aside from data preparation, then it's all about training and inferencing. And so this is the I guess again the super simple form of all of this. And so think of training as the weeks of school and homework that you suffered through, and then the inferencing part of it is the test that you passed because you did all the homework. Or, for example, your parents, what a cat looks like because your parents taught you, by showing you tons and tons of pictures of cats. Cat starts with C, all that stuff. And then you learned what a cat looked like. Maybe the first time you saw a raccoon, you thought it was a cat, but then you started to learn that, there are different things, traits that make it more raccoon-like. And so that's the idea. And so you start with that training data set, and then you need a neural network. And this is an untrained network. You can get some of these from NVIDIA's NGC. And so you can see at the bottom, there's a link, nvidia.com/NGC. That's NVIDIA GPU Cloud. We've got lots of networks you can download there. And I've got to just do this real quick. And then so once you have this untrained network, what you have to do is start running these images through. And so at the top of this untrained network, there's a layer, and that's why there's multiple layers, and that's why they call it a deep neural network, because these layers go really deep. And so so you see this is a very simplified example just for the purpose of explaining. And so you have 4 input nodes and at the top, and then you have 2 input nodes at the bottom, and then just between them there are a few hidden layers. So the white lines show that the nodes in the input layer share the results with the nodes of the first hidden layer, and so on all the way down, or the green lines rather. And so that's kind of the way. And so when you enter those cat images, it starts to add weights to what makes that a cat. Pointy ears, whiskers, the little nose, all of that. And so it starts to know what is a cat, and then you're getting emphasis on the things that make it specifically a cat, and then telling it what is not making it a cat. And so it starts to identify those things, and then you have a trained network once you've done all this training and retraining, and then you can run inference. And so now at this point you have a trained network. You can drop in an image of a new cat that it's never seen before, and depending on how well the network's been trained, it'll give you extremely accurate results. So that's the very basics of it. And so and there are lots of different neural networks as we talked about. But anyway, so this is a GAN. So that's again a basic one, and what I'm showing you here is a GAN. And this is called a generative adversarial neural network, very common to be used in media and entertainment for doing things like generating people and pets and environments even. And so there are 2 parts of the network. There's a generator network and a discriminator. And you can think of them as like an art forger and an art critic. The generator, really what it does is it learns to create a plausible image, and in this case, and the discriminator learns to distinguish fake data from real data. And so the art forger keeps attempting to fool the art critic until the art critic finally, at some point, accepts this as a true image, and then that's the output. So just a very simple way to think about a GAN. And so, and the reason I shared those with you is because these keep coming up, and so you're going to see them throughout here. So really just on the democratization part of this whole thing, these are how some of our partners are bringing AI to life in commercially shipping video applications and image editing. So you can see Photoshop, like what you're looking at there really is, this is the domain of experts that would ordinarily spend a lot of time trying to get a result, like from the young person to the old person, an aging process here, or even de-aging, but in this case, aging. And so, but this is using Adobe's neural filters that you've probably all heard of, Sensei. They get an amazing result with much less effort. So it's really an accelerator for people. It's also a creative collaborator, I like to think of it as, because there's still a human interaction, and the human still has to choose what the final result is that's going to connect with an audience. Color matching, of course, face refinements and face tracking. We're going to talk a lot more about that, because there's a really important thing that's happening right now that maybe some video folks aren't really considering, and that is 2D and 3D are starting to really come together. There's like some kind of convergence happening where you're able to generate 3D from 2D, and you're able to use 3D to control 2D. So there's a lot of cool things happening there. A couple of other interesting examples, and actually I'll show you a bit more of that. Here's some more on Sensei. Instead of wasting a creative person wasting their time masking, this is a really fast way to get a quick result. So AI is being used to automatically detect different parts of the face. Like I showed you earlier, this is like a segmentation task. Where are the eyes, where's the mouth, where's the nose, that sort of thing. Here's an example of using different inputs to find images. So here you can select a color, and it's like, okay, well, you may have started with Eiffel Tower, maybe it's tagged that way, but then maybe it's not tagged with mood or with color, and so you can just make a quick selection there, and then it gives you Eiffel Towers that look like that. Another great example is that Autodesk Flame now has a Z depth map generator that you can extract a depth map, basically from 2D video. And so this lets an artist be able to do things like, just quickly do depth of field like work and that sort of thing, or color grading in specific areas without, again, having to go through the whole process of masking every little piece of it. And then they also have a human face normal map generator, and what that does is it creates a normal map from a face. It can recognize different features in a face, and then with their machine learning algorithms, they basically extract that normal map, and then you can use that tool really to do things like relighting a 2D face, which is super cool. Makes that process way easier. You can also do other things like facial recognition with it. If you wanted to, I guess, take it that far. But really, it's more for relighting, doing digital cosmetics, beauty retouching, that sort of thing. And then Blackmagic Design has their DaVinci Neural Engine, which is used as really state-of-the-art neural networks to do features like what you're seeing here, color matching, which is an obvious one for DaVinci Resolve. But then also doing things like speed warp for motion estimation and retiming, super scale for doing up-res, and then auto color correction. And they can do facial recognition as well for auto organizing your bins. So just to get your edit prepped really quick. So here's just a video that's showing some more of DaVinci Resolve's functionality. Object removal, super simple. Then you're also seeing, we'll see it in a second here, retouching clips. So this is a quick way to do facial refinement. Again, much faster than traditional methods. So it just saves artists a lot of time. And this is just doing a slow-mo, so speed warp. And I'll show you more examples of super slow-mo later. Here's a cool one from Adobe again. You saw a sneak peek of it earlier, but this is auto reframe. So imagine someone's watching content on a phone now, and they go into vertical mode. You still want to keep the highlights in frame. So just an awesome way to do that sort of thing. And some of the examples that I shared do run in real time using NVIDIA GPUs. And so we announced NVIDIA RTX, I think 2018 at SIGGRAPH in Vancouver, and hopefully we'll see some of you there this year. But for us, it was really the single greatest leap in GPUs since CUDA was introduced back in 2006. And so really, there are a number of parts here. I'll just real quick, there's a streaming multiprocessor here. This is for advanced programmable shading. So when you hear 10,000 CUDA cores on an NVIDIA RTX A6000, that's the SM. The RT cores are for ray tracing specifically, so just to help accelerate BVH traversal. And then we have tensor cores, which are used for tensor operations or AI. So again, giving an extra boost to that. Memory, which is super important in our professional GPUs. I'll give you an example of why we have like way more memory in those, and it's particularly important for AI. Display, of course, and then NVLink, which you can combine two GPUs together with an NVLink bridge, which would basically double the memory. So you could go from a 48 gigabyte GPU to a 96 gig pair, and of course encoding and decoding. So we have encoding and decoding on the GPU, and why that's important for AI is because we increase the number of decoders on our GPUs specifically to bring video into the GPU quicker so that you can run your AI operations and then get the video back out. So that was a key thing as well. So here's just an example of why memory is so important. On the left, you have 8 gigs of GPU memory and then 16 gigs. This is choppy already, and this is super smooth. Maybe it's not translating well on Zoom, but that's what I'm seeing is super smoothness. And then here, now we're going to apply an AI filter here. So we're doing a super slow-mo. And then we're going to try the same thing here, but it runs out of memory. So, if you're considering doing more with video, more with AI, just really consider the memory implications because it is super important. So now we're going to switch gears to NVIDIA research and some of the work we're doing in AI, and I'll start with video.
是第一财经的记者，我今天呢来为 NVIDIA 录制这段视频，让大家看一下 NVIDIA。
Maxine helps me keep eye contact with everyone on the call, whether it's one person or 100.
Some current uses of synthetic biology involve creating biofuels. engineering bacteria with useful properties not found in naturally occurring organisms, developing biosensors capable of detecting environmental toxins, producing biopharmaceuticals, and manufacturing chemicals via fermentation rather than petrochemicals.
So that was a little bit of the sneaks. You're going to see a little bit more in depth on some of those, not all of them. But so here's super resolution. I'm sure you all remember when this was like CSI wizardry, where you keep zooming in, and suddenly a license plate resolves. And we all thought that was funny. Those of us in the video world who knew what was possible at the time, but now it's kind of it's getting to the point where it's possible, and AI is making it so. And so again, this is just an example of AI super res, and traditional methods, and then deep learning. And so I'll just go back and take a look, specifically around these areas. You'll really see the difference. And I'll switch again now. And so that was up-resed right there, bicubic up-res. So it's already up-res. This is not the low-res version, and this is the deep learning version of that. And here's just another example. Again, these methods served us really well years ago. The nearest neighbor and bicubic filter, but you can really see the difference that AI is making in some of these areas. So this one here is more if, I thought I'd show this one because if you're interested in virtual production, this is relevant, but which is kind of video, but also 3D. And so this is DLSS. DLSS is deep learning supersampling. And so ray tracing graphics is far more beautiful than rasterization, and typically on LED volumes for virtual production, a lot of people are rasterizing still. Some people are actually now moving to ray tracing, but it does require a lot more computation per pixel. So the solution really is to ray trace fewer pixels and then use AI on our tensor cores that we talked about to up-res to a high resolution and then boost frame rate. So that's really important. That's what allows it to maintain high frame rates while you're doing this. And so we really built a supercomputer around this, and then we trained the DLSS model on high quality 16K offline rendered images of many different kinds of content. And then once the model was trained, it gets downloaded to a driver, and then at runtime, what happens is DLSS takes a low res, and you can, maybe you can't see it here, but basically what it's doing is it's taking a low res image, and then it takes the motion vectors of that, but then it also takes the previous frame. So once the previous frame is up res, takes the motion vectors and both of them together, and then it generates a new frame. That's the basic idea of it. And here's an example of what it looks like. So there's native 4K on the left, and then DLSS on the right. And here's just an exploded view of what you're seeing. So stay tuned on that 3D space, because there's so much happening there, and it's really going to be changing how we do video as well. Yeah, and so just more on virtual production. Epic and NVIDIA have been working together a long time. We brought DLSS into Unreal, and so you can get access to it there, and Unity as well. So let me just keep going. Here, basically, this is more about video walls. So some of you are interested in video walls, and I thought I'd put this in here for you. We have software that comes with our professional GPUs, and that lets you do things like bezel correction, warp and blend, and mosaic and scaling, basically. And so there's also something called QuadroSync, which is a daughter card that lets you synchronize the output of multiple NVIDIA GPUs with displays or projectors for large-scale visualizations like you see on the far right there. And yeah, and then also with our professional GPUs, that's what lets you get things like Genlock and GPU Direct. So I mentioned denoising for rendering and ray tracing and DLSS and some of those things, but there's lots of noise in video, and so I thought I'd share this with you because AI can equally be applied to denoising in video. And so, this is just showing you on all different types of noise how AI can help clean up images and video, with some pretty dramatic results in some of those cases. And completely different type of noise there. So, all right, let me keep going here. This is super slow-mo. You saw a little bit of this earlier. That's just the music. So what you're seeing is manual slow-mo, and you're seeing the choppiness of the frames. Super slow-mo is actually doing a frame boost. So it's inventing frames where they didn't exist before, so that you can get a much smoother action. So, perfect for broadcast and replays where maybe you didn't, or you have different types of cameras on the field, and maybe you didn't get that 120 or 240 FPS video. You can still get a different angle, frame boost it, and then have a slow-mo from that view. So content restoration is also a hot area. NeuroLove's one of the companies that's tackling this for content creators, and this is just some of their work. They had a breakout moment. Dennis Shuryev is the founder. He had a breakout moment when he first did this video. It was the arrival, and you see the before and after. I'll show you the full video. This was the arrival of a train at La Ciotat station, and you can see what's happening there. It's pretty bad. And so here's the final result. Much smoother. And what's really fascinating about this, if you saw the what Peter Jackson did with "They Shall Not Grow Old" or "Get Back" from the Beatles, I mean, this really transports you into the world far deeper than before. It's almost, for me, it was like seeing it for the first time. You can really get a sense for how life was back then better, because it's not this weird abstracted thing anymore. It just looks much more real. And then there was a version of this in San Francisco, and so what you're seeing in some of these examples is the frame boosting, the cleaning up of the image, the colorization, and then finally you're hey buddy. And then you're getting this amazing result. So that's kind of the idea. We also have something called NVIDIA Maxine, which is really we're developing these state-of-the-art SDKs that really, the intent is to reinvent video communications, and we have some partners in the video conferencing space that are using it already. And so it's, but although it's positioned for that, just because of some of the features that it has, it's organically gained traction in studios and software providers on the content creation side. So I'll just show you an example here. So this is our video effects SDK. There's an audio one as well.
Upscaler and super resolution improve video quality by enabling higher resolution streams. Artifact reduction removes compression artifacts, ringing, and mosquito noise from encoded video while preserving details of the original video. Video noise removal reduces lens noise, webcam photon shot noise, and salt and pepper noise that usually appears in low-lit environment. Virtual background enables you to remove, replace, or blur a background in real time.
And then there's the AR SDK, and this is where things get really interesting, as I mentioned. This is where we start seeing the worlds of 2D and 3D collide.
Face tracking determines the location of the face in images and video feeds and specifies the size using a bounding box. Face landmark tracking recognizes human facial features and facial contour, including face shape, lips, eyes, eyebrows, and eyelids using 126 key points. Face Mesh uses a 3D morphable model. Body pose estimation predicts and tracks 34 key points of the human body in 2D and 3D. It detects human figures, estimates 2D key points, and derives 3D key points to accurately and adequately represent human form. Eye contact adjusts your gaze to look at the camera regardless of where it is positioned. Audio to Face animates a 2D or 3D digital face with high fidelity based on just an audio input.
Yes, there was recently a sign of extraterrestrial life on Venus. What else do you want to know?
AI Face Codec will enable smoother video and bandwidth reduction up to 10 times.
Hey everyone, this is Victoria. I hope you're all doing well. So today we're going to be catching up on the latest from NVIDIA research.
Audio, Rick.
Major bandwidth savings on that last one. Thank you, Jeff. Here's just another example of AI pose estimation. It's just using a single camera to capture the pose, and then he's controlling this 3D character. So let's talk about style transfer quickly. So style transfer is basically taking content from one source and the style from another, and then combining the two, and then you get a final output. So you can see the content, the trees and the water and all of that, and then over here you have the style being transferred. So this is being used in a number of different ways. Again, just more examples. Reference image. There's the input, the reference image, and then the output. And you're just changing the reference images in some of those cases to get a different output. You keep the same input. And we're going to get more into human faces. Here's style transfer on video. So taking the original video here, and then we're changing the style over here. So you can see, it's Picasso painting in his competitor styles. I don't know. They were competitors. I don't know if they thought about it that way. I'd like to go back. So what you're seeing here is semantic manipulation. And in this video, what you're seeing is this is a semantic map. It's how the data is all labeled. And then there's the original output, and then you can change buildings to the buildings here into trees, and then trees to buildings. This is still research, but it gives you an idea of some of the things that are coming. Here's another example of changing the environment on the fly in real time. And so pretty cool stuff. And then here, just an example of different methods of doing this. This is NVIDIA's, and you can see that it's much smoother, temporally stable. You're seeing a lot of flickering in some of the other examples here. So that's kind of the idea. I wanted to show this real quick because Munit was like next level style transfer, and there was an input which could be a drawing. There's a ground truth, and then it would do sample translations. Again, here input, ground truth, and then sample translations. I want to show you that because here's an example of it similar to what I was showing you earlier, and this is a way that lets you more easily edit this kind of video. And so, and this is doing face to edge to face, and so you see the input, the edges, and then it gives you a new output. And then multiple outputs. So, and you can change this. This is a little, and you can see how smooth it is, temporally stable, all that goodness. And then here we have body pose. So what we're doing here is this is the input, and so there's a body pose that gets extracted from the input, and then we can translate that to the output. So this is basically taking an image of this person and making her dance like this person. So we could take Marty and we can give him some new moves if that's what we were hoping to do. This is just taking a database of images. It's called the CelebQ database. It's all these celebrities, and then basically training it. And then there was a progressive resolution thing as well. So just taking lower resolution and progressively moving up the scale, and then interpolating those celebrities. And so then what you end up with is a set of humans that have never existed before that kind of look like celebrities. So you're looking at them thinking, wow, they look fantastic. Maybe they're a celebrity, but they're not. They don't exist. But of course, results may vary. So here's just an example of taking a low resolution to generate a high resolution image. This is using the style transfer. What's interesting about this one, you're taking different styles and applying them to a new human. So what's really cool about that is if you wanted to create a crowd scene, you wanted to create it in a specific part of the world, you want to do it based on ethnicities, you want to create families, you want to have specific genders, whatever it was, you can create humans, and there are more controls now to be able to do that sort of thing. Here's another way of doing it, just as an example with, again, just with drawings and then with semantic map-like things. So when you don't have enough detail, the AI can fill it in. And this was just similar to what you saw before with Ganverse 3D. This is generating 3D face models from a single image. All yours, Sepi.
Awesome. Thanks, Rick. Cool. Now that we've seen how AI is used in content creation, I'm going to take you through the next step in its journey, which is content management. First, let's take a look at some of the trends that make the use of AI in this stage a necessity. No doubt, the volume of content that's being created is growing exponentially. We hear it all the time. There's more content out there than ever before. Parallel to this growth, though, is the expansion of the library of assets that are being used to create the content. Assets like characters, vehicles, furniture, environmental elements like clouds and trees. And because audiences are consuming media on multiple formats and devices, many different copies of the same piece of media needs to be created, just in different sizes. And so essentially what that means is that libraries are getting bigger, and managing these libraries requires tagging what's needed and deduplicating what's redundant. Tagging is particularly important because that content has to be used in many different workflows. It not only speeds up content development when you're searching for a specific asset, but also acts as the basis for monitoring content so that it meets the standards and guidelines of both platforms and advertisers. And so what this means is that content management is critical for revenue because it's often the starting point for licensing and ad insertion. So the scale of these libraries are now so large that automation has to be utilized, and this is where AI comes in. Computer vision can be used to identify elements within an image, and then models can be built and trained based on that information for tagging those elements. And elements can be automatically tagged for different topics, categories, people, sentiment analysis, and a whole lot more. Inference can be used to scale out that training and make predictions when analyzing those libraries in full. And natural language and image-based search can be used to make finding assets within those libraries more intuitive. This demo that I'm about to show you is from NVIDIA Omniverse Deep Search, which illustrates image and natural language-based search. This example is for game development, but really the same principles apply for any type of content.
Game development is an extremely complex process, with hundreds of thousands of assets made across dozens of teams. 3D asset libraries are becoming more difficult to search through. Together with Activision, we are exploring the ways Omniverse can help game developers build games faster. With Omniverse Deep Search, game developers can now search intuitively through enormous 3D libraries using natural language or images. The developer can simply place the 3D asset from Deep Search into a fully interactive, path-traced scene. Using Omniverse's advanced simulation and physics capabilities, designers can configure, adjust, and place physically accurate objects with just a few clicks, doing in seconds what was traditionally a time-consuming process.
Great. So closely tied to content management is content distribution, and many of the capabilities cross over from one into the other. The primary purpose of AI in distribution is to make content as accessible as possible. Some of the trends within this stage have been around for some time. Trends like the global reach of media. Content needs to be delivered to a global audience. They consume entertainment in all different languages. And because there's so much content out there, it needs to stand out from the crowd and be promoted. And given the size of the libraries that are on the different platforms, this promotion needs to happen at scale. Some trends, though, they're a little bit more recent. Trends like customizing viewer experience by delivering content as object-based media. That is splitting content into individual assets like audio and video, going as far as splitting them into individual sounds, video frames, and visual elements. And these would be the objects within object-based media, and tagging them to determine how they would fit together and delivering them as individual objects to audiences. And this gives audiences the opportunity to pick and choose what elements they want to see and hear. And it allows for a customized consumption experience. So we're seeing a lot of AI solutions that are being built around delivering capabilities that are aligned with these trends. For instance, we're seeing AI that can automatically subtitle and translate content so that it can be consumed by audiences anywhere. AI can also be used to automatically create highlight reels. It does this by viewing a piece of media, whether it's a sports broadcast or a film or a television series, auto-selecting key moments and editing footage together into a short reel that promotes the content. And because it can do this at an enormous scale, it can be used to promote content across a massive library in a short period of time. Finally, AI can be used to separate and tag objects within content for object-based media delivery, allowing consumers to customize their media experiences. This is the focus of many R&D departments today and is going to be a big part of the future of content distribution. So let's take a look at some demos that show AI in action in this stage of the content lifecycle. In this demo, we see real-time AI translation and AI subtitling with NVIDIA Maxine.
NVIDIA Maxine reinvents real-time video communication with the magic of AI. Thanks to Maxine, we can now hear and see each other better, and we feel more connected and included, even when language becomes a barrier. To stay engaged with my audience, Maxine helps me keep eye contact with everyone on the call, whether it's one person or 100, and even if I'm reading a script.
¿Cómo puedes superar las barreras del lenguaje con Maxine?
While I don't speak Spanish, with Maxine's help, now I can.
Ahora puedo hablar tu idioma con mi propia voz. Impresionante, ¿no? Magnifico.
Pas mal, mais est-ce que Maxine comprend aussi d'autres langues?
Oh yes, absolutely.
Maxine me permet aussi de parler français et bien d'autres langues. Wir würden mehr über die Magie von Maxine erzählen, aber du musst dich bis zur nächsten GTC gedulden. Bleib dran, damit du nichts verpasst.
Wunderbar, ich bin dabei.
We can see how some of these capabilities become crucial for content distribution. And that's not just for really big distributors like professional broadcasters or film studios. It can be for content creators of all sizes. Imagine that you're interviewing someone for a show or live streaming to an audience on a platform. There's a lot that AI can do to elevate the distribution of your content and ultimately the audience's experience. In this demo, we're going to see NVIDIA Broadcast app, which runs on NVIDIA RTX and is free to download and can help take your content distribution to the next level.
Hey everyone, it's Cynthia from NVIDIA here to talk about some cool new updates for the NVIDIA Broadcast app. Last time, we checked out some awesome features like noise removal, which comes in handy when there are noisy interruptions like the construction outside right now. Let's get rid of it. It's perfect for when you want to be heard without yelling over bothersome background noise. Great for video conferencing and live streaming. We also covered virtual background, a cool app feature that enables streamers to blur their backgrounds, which lets them add a cool blur like those expensive cameras. Or they can just change their backgrounds entirely and be anywhere or everywhere at once. It's even great for live game streams too. And we can't forget about autoframe, the feature that tracks with you no matter where you move on cam. See? 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 Always on me. But the cool thing about the NVIDIA Broadcast app is that we're always adding amazing, cool new features. The first is room echo removal. Here I'm in a co-working space. And do you hear that echo in my voice? That's room echo, so let's remove it. With a click of a button, our AI will filter out the echo from your microphone for better clarity and presentation quality. Another great feature is video noise removal. It's nighttime right now and I don't have a fancy lighting system. But with video noise removal on, the visual noise is reduced and I can get a better quality stream in low light situations. And another cool thing is that you can stack the app features on top of each other and use them together. With the background blur on, you can auto frame on top of it like this. And you don't even have to worry about background noise or room echo interrupting you. So whether you're working or studying from home, a streamer making content, or even just a gamer hanging out with friends online, we're talking about better quality sound, higher quality video, camera tracking, and background features all in one app. It's pretty cool. Download it today, try it out, and share your feedback.
All right. The final stage of the content journey is in how audiences consume it, a stage where AI continues to play a role. The goal in this stage is really all about higher engagement and retention of audiences. And this goal, again, drives a lot of the trends that we see. Trends include the emphasis on gathering viewer data and using those insights to discover what audiences enjoy and, equally crucial, what they don't. This information can help determine content strategies, and it can be used to deliver a more personalized experience to audiences on platforms. This personalized experience includes what pops up on a viewer's dashboard, what's recommended to them in their search, and even how that content is promoted to them. Personalization leads to higher engagement and retention of audiences. Finally, we know interactivity and engagement go hand in hand, and what we're seeing is more content that allows audiences to interact with it in some way or is enriched with data that audiences find compelling. Examples include player stats in a sports broadcast or branching narratives within entertainment where you can choose your own adventure as you consume a piece of media. AI capabilities and content consumption that address these trends include data science to gather viewer data and output those insights, recommendation engines and conversational AI to suggest content audiences will find compelling, and data-driven visualization to deliver interactivity and content. So let's take a look at some examples. Just hit play in this. This example is from NVIDIA Inception partner iSportistics, who provides video interpretation and tagging for sports content, and they do it with AI. This shows how AI can be used to enrich content for viewers. So you can see you can follow the ping pong ball and follow the snowboarder. Finally, we have a video demonstrating the natural language capabilities of Omniverse Avatar. Omniverse Avatar connects core NVIDIA SDKs. These include Riva for speech AI, Metropolis for perception, Merlin for recommendations, Fleet Command for scaling, NVIDIA Maxine that we looked at just a little bit ago for live portraits, Omniverse for animation and rendering. Imagine these capabilities used to recommend content based on natural conversation with viewers, suggesting films they might enjoy or when their favorite team is playing next. So let's take a look at that.
Hi.
Hello. Hello, Toy Jensen.
Hi, please ask me anything.
What are the greatest threats of climate change?
The greatest threats of climate change are the effects on human health, food security, water supplies, and the environment.
How do astronomers look for exoplanets?
Most exoplanets are found via the transit method. That was the case for the TRAPPIST-1 planets.
Tell me more about that method.
The transit method is when a planet passes in front of its star. The amount of light block tells astronomers the size of the planet. The duration of the transit tells astronomers the orbital period of the planet.
What telescopes use that method?
The Kepler Space Telescope used the transit method to find thousands of exoplanets.
I've heard about a satellite called TESS that is used to find planets. How does it work?
TESS is a space telescope that looks for transits.
What roles do proteins play in our cells?
Proteins are the building blocks of the body. They are the basic materials from which all living things are made. They are needed for the structure, function, and regulation of the body's tissues and organs.
How do they work?
Proteins are made up of amino acids. Amino acids are the basic building blocks of proteins. There are 20 different amino acids that link together in different combinations to form different proteins.
How do they catalyze chemical reactions?
Proteins are biological catalysts. Catalysts are substances that speed up the rate of a chemical reaction without being consumed by the reaction. Enzymes are proteins that increase the rate of biochemical reactions in the body.
Thank you. Goodbye.
Sure, anytime.
And that brings us to the end of our presentation.